Okay, we are now in Chapter 9, Thinking, Language, and Intelligence. Okay, I got some pictures off the internet that kind of illustrate each of these concepts, thinking, language, and intelligence. Let's go ahead and just dive right in and talk about thinking. Thinking, there are three main topics that we're going to cover with regard to thinking. We're going to talk about what concepts are. We're going to talk about problem-solving strategies and some of the problems that we have as problem solvers. And then we'll talk a little bit about how animals think and what we know about how animals think. So let's start with concepts. Okay, I've got this beautiful beach. Oh, looks awesome. Brings to mind some concepts, I'm sure, when you look at it. A concept is a mental grouping of similar objects, events, states, ideas. Can even be people. Could be just about anything. The idea is that it's a mental grouping of similar things. So when you see this picture of the ocean and the chaise lounge on the ocean, it probably brings to mind something that relates to this. Maybe you've had a vacation like this. Maybe you've longed for a vacation like this. Grouped in this concept of vacation is probably a bunch of different aspects of what it means to be on vacation. Maybe getting a tan, relaxing, maybe having drinks or going dancing. It could be a cruise. It could be that you associate flying there. The idea is anything that goes along with the concept of vacation would be grouped together in a mental grouping. And anytime you encounter something sort of similar to any part of your concept of vacation, it'll bring to mind vacation. Okay, now within a concept, we always have a prototype, a best example of a concept. I found a concept car on the internet. I like how not only is the car drawn in this conceptual fantasy way, but they went ahead and fixed up the hills and stuff to make them look like they are fantastical also. The reason why I got a concept car is because in Detroit, or wherever cars are made anymore, they always have a car show, and they'll roll out their prototypes, their best examples of their concept cars. These are cars that aren't yet ready to go on the market, but they want to start getting some buzz going and get people excited about it. They're using the terms exactly the same way that we do in psychology, that you have this concept, this mental grouping, it's in your head, and then you have a prototype. In the case of concepts in psychology, that's also in your head. It's not something concrete like the concept car is in Detroit, but your prototype is always going to be the best example of a concept. Now the thing is, when you're conceptualizing something, I've got something dumb like a chair. All these things are examples of chairs. Well, of things that may include components of your concept of a chair. Like your concept of a chair, if I said, what's your definition? You might say it's something you can sit on. So some of these are things that you can sit on, but are not technically chairs. Like a chest is not really a chair. A fence is not really a chair. Swing at least is designed to be sat on, but it's not a chair. The chaise lounge isn't even technically a chair. Which one is closer to your prototype? Probably the one in the bottom center that is legitimately a chair. 4 legs, has a back, has a seat. So it's probably closest to at least my prototype of a chair. I wouldn't say a fence is my prototype of a chair, my best example of the concept of chair. But which of these fit the chair concept? Well, for me, I'd probably say the chaise lounge, the chair, and the swing are all conceivably things that were intended to be sat upon, so they would fit into my concept of a chair. The chest is a multi-purpose thing. I have a chest that was handmade by my husband's grandfather, and we try not to have people sit on it because we're like, he like put together several planks to make the top, and I'm not exactly sure that they can, withstand somebody sitting, you know what I mean? So by definition, a chest is not always something to be sat on. Same thing with a fence. I mean, this one looks like a nice sturdy one, but some fences are really not up to the task of being sat on or climbed on or whatever. Right? So what we're talking about is which one seems more like a chair, which one could you more readily construe as a chair. That's what we're talking about when we're talking about concepts. There are different layers. Now, another issue we need to talk about when we talk about thinking is how do we solve problems? Okay, he's got a problem. He's looking for something at the grocery store. Where's the cottage cheese? Or where's the juice? Ah, he's probably looking for some kind of juice, right? So one way that he could solve the problem of I need juice and I'm in a grocery store, where do I go? Is he could use an algorithm. An algorithm is where you take a step-by-step approach to solving the problem. So an algorithm in this case might be check the supermarket's map. They all have them. I just recently found this out. Every supermarket has a map of where you can find stuff. So I guess step one, become aware that there are maps would be the step one in the algorithmic approach. And then step two, look at the map. And rather than wandering around up and down the aisles or guessing or anything like that, find it on the map and go there. I guess another variation on that same kind of algorithmic approach, rather than looking around, would be to ask a sales clerk, where's the apple juice? So anything that involves a logical set of steps that guarantees a solution is what we mean by an algorithm. A heuristic is more of a rule of thumb approach, where you use your past experience to help guide you in your solution to the current problem. So anybody who's shopped in the grocery store probably thinks that they probably would cluster similar items together. So as you're walking past the ends of the aisle, you're looking down and looking for anything that looks like beverages. It could turn out to be the soda pop aisle, and maybe they don't group soda pop with juice. Maybe you want the specialized juice that has to be refrigerated. Of course, if you want the specialized juice that has to be refrigerated, then you know to go to the exterior walls probably. Most stores, that's where they keep the refrigerated aisles. My grocery store has a few aisles of frozen in the middle, but no refrigerated stuff in the middle. Of course, the new store down the street, it's a Fred Meyer, and it has some refrigerated stuff that is in the middle. And trips me out every time. It's like, where is your cheese? Oh, it's in the middle of the store. Insight is another, I don't know if we can call it a strategy. It's another way that problems get solved. Because in insight, the solution just comes to you, even though you weren't necessarily working on it. Sometimes insight comes to us when we're asleep. Sometimes insight comes to us as soon as we stop thinking about the problem. The solution finally pops into our head. That's insight. So you suddenly realize the pattern of the items in the store, and then all of a sudden you realize, oh my gosh, it must be in the back. Okay, well, I'm going to go back where the refrigerated stuff is. So you suddenly realize where it is. Oh, here it is. Oh, okay. I sent my husband to the grocery store one time searching for powdered buttermilk. It's like, dried buttermilk. And you can use it in recipes in place of the moist kind, just add water. And it doesn't go bad as fast, right? So like, go find me powdered buttermilk. I know it exists. I just saw it on TV, so I know it exists. So poor dude. He was trying all these strategies. He asked for help. The employees didn't know where it was. He guessed where would they have powdered milk, wandered around, looked for that. Finally, insight. As he's staring at the array of stuff in amongst things that had nothing to do with it, it's on the baking aisle. He finally spotted it, and the insight happened. Occasionally, that's how you go grocery shopping. You get an insight. All right, so just to make it a little easier for you to follow along, I put these little note-taking parts. An algorithm is a step-by-step strategy. Now, the thing about an algorithm is that it can be time-consuming, and it's the reason why a lot of us don't go to an algorithmic solution first. It takes time to go find the map. by the time I found the map, I might have found the apple juice, right? So why am I searching around for a map when I could just go search for the apple juice, right? But it may take a little bit of extra time, but you know you're going to walk out with apple juice. You're going to solve the problem. With heuristics, this is a rule of thumb strategy, and this is our favorite method for solving problems in our everyday life because it's quicker. The problem is we're more likely to commit errors when we use the heuristic technique. If you're walking through the store checking for aisles with beverages on them, you might walk past the aisle that has the juice on it because you weren't expecting it to look like that, or you weren't expecting it to be in the position that it was. Heuristics oftentimes can cause us to leap to conclusions, to ignore details, things like that, and so it's much more error prone. But it's quicker, and really the rule for humans is we would rather be quick than right. Because a lot of times we never find out that we were wrong because we've moved on to something else. And so quick answer, move on. Quick answer, move on. And in most the decisions that we make in our everyday life, it's not that important. Is it life and death if you walk back and forth in the supermarket a couple of times looking for the apple juice? Actually, it's probably good for your life to be getting extra exercise, right? I mean, in the long run, we go, who cares that I wasted some steps? And so we don't care that we were wrong or that our approach was inefficient. Insight occurs without intent, and so by definition, you can't do it on purpose. So don't sit around waiting for insight to come to you, right? In fact, don't sit around if you're hoping for insight. The best way to get insight to pop into your head is to change scenery, go for a walk, work on something else. That's the best way for an insight to pop into your head. But if you're on a time crunch and need to get this problem solved, don't sit around waiting for insight to hit you. Go ahead and pick one of the other techniques. Okay, I have a problem for us. Exactly at sunrise one morning, a Buddhist monk set out to climb a tall mountain. The narrow path was not more than a foot or two wide, and it wound around the mountain to a beautiful, glittering temple at the mountain peak. The monk climbed the path at varying rates of speed. He stopped many times to rest and to eat the fruit he carried with him. He reached the temple just before sunset. At the temple, he fasted and meditated for several days. Then he began his journey back along the same path, starting at sunrise and walking, as before, at variable speeds with many stops along the way. However, his average speed going down the hill was greater than his average climbing speed. Okay, so our problem for this task is to prove that there must be a spot along the path that the monk will pass on both trips at exactly the same time of day. So, how do we approach the problem? Well, we don't have the opportunity to share ideas right now, so I will tell you ideas I've heard. Sometimes students will raise their hand and say, maybe there's a lunch area on the mountain, and the monk has lunch and happens to be sitting there on both times at the same time of day on both trips. That's a heuristic solution. Using your logic, your past experience, that there might be a picnic area and that he might loiter at the picnic area across the same amount of time. That's kind of focusing on a spot. The task is not asking us to find the spot where he might have been. Our job is to prove that there must be a spot somewhere along the mountain. So, imagining yourself, I had a student once say that they imagined themselves leaving at sunrise from Seattle and heading east on I-90, heading west on I-90 from Spokane, leaving at sunrise, and the student said, there's no way I'd be at the Snoqualmie Pass at the same time both trips. And I'm like, who said you have to be at Snoqualmie Pass at the same time on both trips? We're trying to prove that there's a spot, not where the spot is. It doesn't say here that he'll be at the lunch area or something like that. It says, prove that there must be a spot along the path that the monk will pass on both trips at exactly the same time of day. So how can we prove this? Well, this looks sciencey. Ooh, nice. Okay, we could draw a little graph. Time is going to be at the bottom, and of course we don't know much about time on this story, right, because they were very vague. All we know is that he left at dawn on both trips, and we know he got to the top of the mountain at dusk. On the y-axis, we'll put altitude to represent the, climbing the mountain, and all we really know is roughly he started at the bottom and he climbed to the top. So it's really very rough graph that I'm going to draw here. Assuming, he is ascending, I just used a straight line because it was easier to draw, but there were times when he took breaks and stuff. He didn't climb the whole time, but it took him all day to get to the top. Okay. Then he leaves from the top and heads down, and he actually went faster on the way down, but my diagram doesn't really illustrate that. Right there is evidence that his path would have to cross. It would have to pass. He would have to pass himself. Monk from trip up has to be somewhere along the path where Monk from trip down would pass him. Now, of course, it's not that spot. It is not that time of day at that altitude. It's the fact that the two lines crisscross is our evidence that shows us that he has to have passed himself. Okay, why am I doing this? You guys are starting to go, what are we even talking about anymore? Why are you talking about this? Okay, remember, we're talking about how to solve problems. A heuristic technique doesn't necessarily solve the question of, is there a spot on the mountain where the monk would be at the same time of day on both trips? Heuristics get us close. We guess that it's likely that he probably would have been at the same place, but we're not exactly able to prove it. If you use an algorithm, which is what I drew here, step by step, let's plot out what we know, and let's draw a graph, and we can prove that there has to be some place because the two lines cross. There has to be a place. Another way that you could algorithmically solve this, which is a little even easier, but I can't illustrate, so I'll get this guy to illustrate it for me. Hey, look, it's even a monk climbing a mountain. Look at that. The stuff you can find on the internet. Isn't that funny? The stuff you can find on the internet. So I've got a monk climbing a mountain. And he's going up. This is, we'll call him Monk 1 because this is him climbing the mountain on the first day. And then here he comes on the second day coming back. And look, ultimately they have to pass. There's only one path. They ultimately have to pass each other. Otherwise, how would they ever get up and get down if they didn't stay on the same path and ultimately pass each other, figuratively? That's another way that we could prove it. We could, instead of having it be Monk from original trip up and Monk from trip down, we could have two people. One starts at the top and one starts at the bottom, both leaving at dawn. They will ultimately pass each other. That's another way we could prove that there has to be a spot where the monk was at the same time of day on both trips. Okay, so if you get algorithmic, you can prove the question. But look at the effort we put into it. That's kind of a drag, right? How about this? Unscramble that word. Okay. Most people can solve it really quickly because you're sitting here in a psychology class looking at an array of letters that look strangely familiar, don't they? Now, if you were a computer or a human who is just bent on doing an algorithm, you would have to try all 782,000 different combinations of those letters to determine what word it likely is. That doesn't sound fun. Instead, we use heuristics. Whenever you are confronted with an anagram, you throw out non-English letter combinations. Like there's no way that you've got an S being right next to, actually all those letters could go next to each other. You would definitely not have two Y's next to each other. You probably wouldn't have the Y before the G. Probably. I can't think of any words that would have the Y before the G. But your brain kind of starts throwing out things that there's no way it could possibly be. And then, of course, really importantly in this current example is you use context. You're sitting in a psychology class. There aren't that many words that have a P, an S, and a Y, and two O's, and right? It's like, I think this is spelling psychology. So heuristics can allow us to solve, in this case, probably faster than sitting here trying to do. If you sat here and tried to do all 782,000 combinations, it would probably take you years to write them out with a pen and paper. Nowadays, computers can do it really fast. So that's actually how they solve problems. They go ahead and do it they do the algorithm because they've got the computing speed and nothing else to think about. Um, for us, it's a lot easier to use the heuristic technique. Now, like I said, heuristics can lead us to errors. And so we can jump to conclusions. Oh, I just saw this over the summer, this new game show came out called the Idiot Test. And actually, if you Google the Idiot Test, there are tests that you can take that are really taking advantage of your tendency to use heuristics to figure out what to pay attention to, what to ignore, things like that. And it's hilarious what you'll miss because you're so busy thinking you know what this question's going to be about. Based on your previous expectations and stuff like that, you kind of get your mind into a particular train of thought, and then they're actually asking you to do something either much simpler or something in a different part of the picture that you've been prompted with, stuff like that. And it makes it really it's a funny TV show to watch because all of us sitting at home not under pressure, it's so obvious what they're missing. And for the people on TV, they can't see it. It's pretty funny. Anyway, I like the name too because the Idiot Test is not a flattering game show to be on, right? And then I lost the Idiot Test. So it's pretty funny. Okay. I think I've probably gone on long enough, so let's come back in the next segment and talk about some of the things that prevent us from being great problem solvers.